I'll show you one more time. Delete the element. I have a surface like this. I'll go to F12. I know the element size. Select the faces. Give this thing 25 elements. The elements has been created. Once elements has been created, go to return. Go to 3D. In 3D, go to solid map. Go to select these elements by face. Here by face. Okay, all these elements has been selected. Or go to line. You have to drag the line. One line is enough. In this path, you select all the 25 mm size. If you select all the solid map, again elements has been created. What you can do, I don't want this.
Yes, I don't Wi-Fi for the next room. Do you know the password what they told? I was not there.
Ask your roommates. I don't
No, no,
know.
I'm on the top floor. You don't have Wi-Fi there. You're using number.
Ask them only.
He asked, I didn't know. Since they were not there.
I don't know. No, they didn't tell me. Nobody told me. They were there. Those guys were there. I don't know. They might have not telling you intentionally. Ask them. You tell that Anna told or something like that.
No,
Other.
he only told me to ask. Okay, thanks.
Okay. Go to F2. Delete these elements, 2D elements by face. Delete it. All the 3D elements are left out. Just go to Shift F11. In the Shift F11, select these elements by attached. Move it to striker component which you have created. Move it. Okay, once you have moved it, you have the striker. Now here property id mat id like this you'll get. Okay, you have to create a property same as like before. Create like this property, you'll get a property like this. Here you have to go for p solid, so p14 or solid, and property is there, right? Go to this p14 solid. In that, this option you want to change, you have to change I solid, you have to change it to HEPH 8 node solid element co-rotational under integrated one Gaussian point with physical stabilization. Select this. Rest of the things you don't have to worry about that. Let it be there. And for the same thing for the alloy wheel also same HEPH 24888. Once the property is created, go for the material. You have to create the material using the property which I have provided here. Young's modulus, Poisson's ratio, uh, only density. Three were used in linear static analysis. Density, Poisson's ratio, Young's modulus. Only three you required in the linear static analysis. But for the impact analysis, you want all the other parameters also. Once you create the material, you will be asked to enter all these values. Okay. First, once you create, I'll create one material. Give a material. Okay. I'll give magnesium. Okay, I'm creating magnesium here itself. I have given the name card image. I have to change it to M2 plastic Johnson Zeril. Johnson means uh, Johnson and Zeril plasticity model. It is plasticity model, material plasticity we will say. Means once the material crosses the yield point, it will plasticize. Material will start to plasticize. Means it is beyond the elastic region. It is in the plastic region. So it is a permanent deformation. For that plasticity model, there are various mathematical model to capture that plastic behavior of a material. This Johnson and Zeril plasticity model is one of the model for capturing the plasticity behavior. So I'll select M2 plus John. Select this M2 plus John from US and give here type plus Johns. Okay, and give row initial. What is the row initial? Was the value for the magnesium? It is 1.84 e power minus 9. I'll copy this value directly. I'll paste it here. Okay. Young's modulus. What is the Young's modulus here? Eng's modulus for this is 44,815. I'll copy this file and I'll go and I'll paste it onto the directly onto the Eng's modulus. Now go to Poisson's ratio. What is the Poisson's ratio? It is 0.35. I'll type 0.35. Okay. Now here you have to clearly say classical input Johnson's Cook parameter. Instead of that, you give one simplified input type active yield stress UTS. This you have to give. Here you have to select for it. If it is in, if it will be in zero, classic input for John. Otherwise, you select simplified input type. Simplified type input type, you have to input sigma y in the sense yield stress, and UTS means ultimate stress, and strain at UTS you have to provide. All those things have been given here. Yield strength at yield strength FTY is 248.211. You have to give 248.211. Next you have to go for ultimate strength, that is 310.264. 310.264. And Young's failure strain is what, 0.04.
This is all data from SE 170.
No, it is from MMPDS. 0.04. Now this has been given, and other parameters we have to give. Yeah, next 0.15. EPS 3 max. Okay, next to these two things, let it be default only, but you have to, where I create magnesium. Yeah, magnesium, right? This is what I was thinking. This EPS max, let it be the default value 1 e to the power 30, 1 e to the power 30. Even if you leave it, no problem, it will be default this value only. And rest of the things, delete. No, that's all. That's enough. Material. You understood, these are the values which I have given. This should be entered like this. And property, I have told you, HEPH you have to select. Rest of the things will be P14 solid you have to select. Material and property is completed. The component you have done is correct. Now go to the property which you have created, select the striker, select OK. So material ID also, yeah, all those two things has been created now. Okay. You create a component. I don't think you can part. Okay. Oh yeah. Okay. Delete it. Once you have created and assigned the material and property for those two things. Okay. Striker, you created the component, meshed it, you created a property, you created a material, and same thing for alloy wheel with 7 point here 25 element size, they are 7.5 element size. You created this, all those things you did. Okay, now rigid body elements, it will be little bit different. I'll show you again here, but there it was simple, right? Create one component RB to create rigid body element. Little bit here, little bit different. No, nothing, no, little bit. Rigid body element doesn't require any property and all. Okay, so I have to create rigid body element for this, right? So what I'll do, I'll go to 1D. Here I have to create a component, right? To go, before going there, I have to create one component. So I'll right click, create component. Okay, here RB2. Here they will say it is called as rigid body elements, not the rigid body elements. They will say not RB2 specifically in radios. Okay, go to rigids and give multiple nodes and calculate node. Okay, go to this and what the heck, this
Bolts को rigid कर देंगे. Only for
yeah,
bolts.
yeah, only for the representation of bolts is done through rigids. I hate this. Fucking hell. Ah, crashed. Oh, what the heck? Okay, then how come you are going to explain your this thing that is, but how much you will understand, you have to practice. You see the video once again. Anyhow, audio also is there, so you watch the videos 1 2 3 times, you'll understand. I'll go on with the cards. Creating cards is easy. These cards, how you have to create is just go to tools. What you have to do now, just go to utility,
Utility.
engine file assistant. Okay, if you are going to do simple analysis, just go to engine file assistant. You don't have to. I have added some more extra cards. Extra cards also, how we have to add, just go to tools, create cards. In create cards, go to engine keywords. In engine keywords, what and all we want, like anime if I want, like, or animation if I want, I can select these parameters. Okay, tools, create cards, engine word, engine keywords, animation and animation. These so many, like, these things are there. If so many dt, these things are there for extra. These things are not required specifically for an analysis, simple analysis if you are doing. So is extra cards. Okay, extra parameter, extra control parameter cards, basic control parameters. If you go to utility and engine file assistant, these are the
Creating
major. See, you have to go for create engine file. This is the major thing. Without this, nothing will happen, nothing will run. Okay, you have to give termination time as 0.02 and give, like, give this thing only, don't give more than this. Okay, I have arrived at this. Okay, 0.02 is fine enough. Point, not even 0.02, 0.005 is also enough. Okay, and nodal time step should be 1 e to the power minus 6 that I have arrived at. Okay, this will automatic and generate out the default output request. You do this in front of sir, whatever the guide you have, right? You input these values, because anyhow I will be providing you the file, right? Hmm. You in, if you import that file, click OK. Now already has been created. So I delete all this. Okay, delete all cards. Nothing is there. Just go to here, engine file assistant. Create this. So I don't know, 0.02, maybe, no problem. 0.05. Here 1 e to the power minus 5. 1 to the power minus 5 here, and it's power minus 6. Okay, just give this. That's enough. You don't have to worry about. Yeah, see, all the things it has only created. Otherwise, manually we can do whatever we want, which I have done manually. This also is fine, no problem. You tell them that these are the parameter cards which we have to give to run. Okay, see, all the automatically you going here, it is difficult for you guys. Okay, who don't know the software cards you can create. And go to the next is the boundary condition. I told you how to create a contact, right? Type 7 contact, the parameters which I have specified plus specify it. Okay, you tell him that these are the I told you, I explained you why you have to type 7 contact is the contact, frictional contact. Okay, it is a type of frictional contact between two. So many types of contacts are there. Type 7 contact is frictional contact which you can give between two components. That's why we are going for type 7. Telling them. Okay, then slave and master you have to select. Master component is based on the stiffness. More the stiffness, you have to select the master. Less stiffer component, you have to select it as slave. And these things, no heat transfer you are not going to do. And major two components are minimum gap is 0.2 and friction coefficient is 0.1. Okay, this should, once you defined all this, now you have to come for utility and boundary condition manager. In boundary condition manager, I'll delete everything first. Okay, I'll delete everything first. Okay. I'll delete everything. Okay, now I have deleted everything. First, come to boundary condition manager. What the heck? Why it is there still? Close. I'll open it one more time. Boundary condition manager. Nothing is there now. Empty is there, right? I will give SPC for wheel. Okay, it is the boundary condition. So boundary condition I'll give, and I'll give nodes. I'll change it to nodes. Okay, select the node. Which node I want to select? I want to select this center node of this thing. Okay, give proceed. Once you are proceeded, select tx, ty, tz, rx, ra, rz. Means 3 translation, 3 rotation. 6 also has been completed, and give create. Now SPC has been created. See, you can see 1, 2, 3, 4, 5, 6 constraint. Once SPC is created, now what you have to do? Now you have to create one more thing. Boundary condition all. Okay. Now once again you give all. Now it will come back. Once you come back, just go here and give SPC for striker. Because why I am giving SPC in the sense constraint, I am constraining this thing and restricting it moving only in x direction. It should not move like this and all. When it contacts, right, when it contacts with this, it tries to tilt, bend and all. In reality it won't happen. When a striker hits from the test setup,
never bend. It is fixed.
Yeah, it straightly comes and hits. So I don't want this to move like this and all. When it going to contact with it, if you don't give SPC, it will do something. So to prevent that, what I am doing, I am giving SPC striker boundary condition. Here I am going to directly select parts. Okay, I'll select this component, give proceed. Directly they are complete. This TX I'll leave, because in TX direction, translation X direction, it has to move. Other than that, everything I'll fix. Okay, you create. Okay, SPC this thing, all the 1 2 3 4 5 6 has been constrained. Here 1 2 3 4 5 6 is only 2 3 4 5 6.
One in direction moving.
Now again you give all, and again you give all. Okay, okay, you give all. Now what I have to give? I have to give the velocity for this. I told you, right, it falls from some height, but we are going to give directly final velocity. We have
Initial
calculated the
velocity
initial velocity 0, so final velocity, final means we are giving component as initial velocity. Initial velocity from this point, but we know that initial final velocity of that component at this point is something like, okay, there you go. Velocity. Here go to initial velocity. From this point the velocity is 16,667. From some point it is 0. From this point it is 16,667. Okay, select this component, proceed, and give in Vx direction 16,666.667. Okay, you create. Now initial velocity has been created. Now if you hide, velocity is there. In well 16,666.67. Initial velocity for each node, it has been applied. Okay, SPC is there, velocity is there, and all SPC is there. Free velocity and frictional contact I explained, and this directly anyhow you explain, no problem. Now you understood, right? How to create, how to same exporting is same. What you have to do here, little bit different. Export, what you do, don't give merge. Okay, merge. This should be unticked. Okay, don't tick this. Okay, merge starter and engine file. Engine file and starter file will be separate. Let it be separate. Don't merge it, and save it somewhere where you want. Here generally there in if you see in linear static analysis, linear static aluminum alloy, if you go to, you have only one input file, right? You have only one input file where you have everything. But in uh, im, impl- this thing impact analysis, what happens, you will have two files. These are all the result files. Each time step it has, means the time frequency I gave, right, it has given one output, animation output, means 1 e to the power minus 5 seconds, it every 1 e to the power minus 5 seconds it will give one result file. I requested like that. Okay, so it has given 333 this thing, another one for graph and all. These two are the rad file. Dot rad is the input file for radios. Dot fem is the input file for uh, OptiStruct. Dot bdf is for Nastran, and dot rad for the mm, radios. Where dot 00, this one is the engine file and this one is the starter. No, this is the engine file and that is the starter file. This engine file has this animation frequency 1 e to the power 5 minus 5 seconds. It has to give that result files. It will like this, how much our what we give, based on that it will give us the result, this one. And this is the engine file. This contains all the node, material data, all everything. See, this is according to the global coordinate system. What is the little bit format will be different here. Format little bit different will be according to the radius format. Okay. Mm, this you have to, this file you have to 000 is there, right? This you have to same how as you did in open the radius, same as like that. Just select this red file 000 file, you run. That's all. It will run automatically and it will give the result. If there is another, it will give an error. So it takes a lot of time, around 4-5 hours or something like to run. Uh, it will, if it is little bit, system is little bit slow, it will take still more time. Okay. uh, Linear static, and this thing is completed. Now to view the results of the this thing, it is almost same but quite different. Okay, now last animation file we have to take, file last 333 is the last file, right? Same thing, just go to here, open. This one is the open. You click on this, you will get this thing. Okay, click on the load model, play, paste the file and give open. 333 here, right? Just click on this, reading the model. Now you got the this thing, right? Now what you do, it is showing here time increments. It is showing, see, all the time increments, how much I gave an interval. It is calculating on the all the time interval. Select the last time interval. Always select all the last time increment. Go here and select the last time increment and go to the contour plot, same as before. Go to some contour plot, select all are displayed and give apply. Okay, now what you do, just play this animation. 333 it is processing. If you play this animation, it will give you the animation. It is impacting like this, and the displacements of this are like this. You can change your parameters. how it is going to impact, and how the material will fail or bend or what will happen. Like this it will clearly depict. Okay, uh, this is how the material behaves at this stress. Okay, at this is the last time interval at which the what is the displacement of this displacement you can see. Okay, this and all I have done the report. Okay, to stress you want means go to this and on this stress select all elements you apply. You get the stress, right? You can give averaging method as simple averaging method will give the smooth result. See, at this point there is a maximum stress. Go to this same uh, measures, use static maximum, and click on maximum. It will show you where is the maximum result. Is 567 MPa is the stress at that location. It will show you the location of it. It will show you the node ID of it. Okay, this is how to plot the results in hyperview for dynamic analysis. Same as linear static, almost same as the linear static. Okay, other than that, if you want to see this scaled version, how you are not seeing much of this means go to here, scale deformed, an option is there, right? Just go here, set the value to 5 times the original deformation. If you set this, see the deformation is more, means the scale of deformation is more. That's all. It's not actual, but it is the scaled model of the deformation. Understood, right? This is of the deflection. So the this thing is that. Then what I left. I think I didn't do anything other than plotting the graph. You have to see this video and practice it. Okay. For viewing the result, you don't have to run. So whatever the file I have the run file, right? You open the same file and you practice the this thing so that once you are confident, you can go with your guide and you can show it to him that whatever.
फर्स्ट पहले उसका एनालिसिस लीनियर स्टैटिक का एनालिसिस कर लेता
Hmm.
हूँ उसका देख लेता हूँ
Linear static is very easy and you will practice, you will learn. It will not just be useful here. In industry everywhere it will 1000% it is useful. You know the software means everywhere it is useful. I told you, right? I also didn't know once I passed out from BE. I didn't know anything. I paid 30,000. I took a training. Then only I learned the software. Nobody will ask the certificate. Nobody. Nobody will ask the certificate. Anywhere you go, I learned 20,000 I gave and I got a certificate from EduCAD. Nobody cares. They will ask, you have the knowledge, you know how to do. That's all. That's why. Mm, you should know the software. You can explore. No, see here also we can see wired mesh, this mesh, and you can see the animation. You can change means you click on this, you can give an animation like bounce. All those things you can explore. You can use whatever this bounce, how these effects, all those things you can explore. These things are there for exploring. Nobody taught me, even in the training they taught only basic. Okay, these are the things. So these are the things for making report. I have made only consistent formatting this thing. I have done different, all those things. For doing the graph, what you can do, I'll show how to import and all, but making graph is little bit different. You just tell him that I exported all the data to Excel and then I do it in Excel. You tell, you mainly focus on pre-processing. While you are showing, you focus. I teach you how to do. There is a video you can practice and you can explore. nobody taught me also the hypergraph. Okay, this hypergraph is little bit difficult, so I didn't use hypergraph. Excel everybody knows, also used Excel. I used to export the data from hypergraph, and then I used to do everything in Excel only. I'll just show you how to do. You don't focus while you are explaining, don't focus on this, you focus on the this thing. Okay, hyperview and hypermesh. You explain him more about hypermesh. Here what you do know, you hypergraph and you open, this is the window. Just open this. I'll show you only three four things. I'll show how to import and how to export the data and how to get it in the Excel. Okay, then you can do whatever the jugglery in the Excel you want. Okay, but you have to be careful. Okay, here we have to import the data file. What is the data file is, in the last of this you will have T01 file. Below this there is a T01 file. You copy the T01 file, go to here and paste this. Okay, now it will see it came whatever. uh, Now what you have to do, what I want kinetic energy and internal energy versus the magnitude, that is time, and give apply. That's all. It will give you the graph. But this graph, see this again, it is in millijoules. I don't want it in millijoules. I want it in, just right click on it, convert units, and give it in joules. Okay, let it be this time seconds, let it be, no problem. Okay, I have kinetic energy and internal energy. Editing this is, in this is very difficult. So what I'll do, go to here. So just go to here, export curves is there, right? Click on export curves. Whatever this export curves is there, Excel is there directly. So what I'll do, I'll go to desktop. I'll export it as export dot one CSV or something. Okay, I'll export it. Current plot, only current plot I want. Okay, displayed access values. Original access values means it will be in millijoules. I don't want it in millijoules. Displayed access values, and apply. Okay, something is there already, so I'll give replace. Okay, now exported data I got. It will be continuous like this. See, two graphs are there in this actually. See, from here another one graph. One is internal energy, one is external energy. We have to do, we have to sort this, means we have to put it side by side so that we can plot the graph. Okay, we got the Excel. I cutted this. I am going to paste it beside this. Okay, now what I'll do, for the namesake I want to understand the internal and external kinetic. Sorry, kinetic. I don't know actually. So what you do, go to data. Yeah, insert. If you go to insert, you have option here, scatter, scatter data. Okay, go to this, scatter with line, smooth line. Okay, select this. Select this. You have internal, external. Select data. Right click on this thing. Select data. Add. Give series name as internal energy. Okay, I'll select x value. Instead of that, what I can. Okay, what I'll copy, paste. Instead of this two, it should be B. Okay, what the heck? Okay. You got the time versus internal energy graph. For this again, I'll go to select data, add one more thing, that is kinetic NER kinetic energy. Select this, select whole thing. Okay. Come back, copy the same thing, Control V, but with this should be F. So I have to do the graph. Okay, simple, not complex thing. I am not teaching all those things. Just internal energy, kinetic energy. All the things will be here only. If you want, okay, you want something like work class energy leave, external force, hourglass total energy, hourglass energy. I'll put these two also. Apply total energy, hourglass energy at the bottom. This you can export and you can import into the Excel. Export it in here. Select these things. Export it using export curves. This always current plot and displayed access values. This you should maintain properly. Otherwise it will be a problem. That's all. Basics of all those things. If you watch these videos, think you will be able to easily practice this video and you can show it to your guide or whatever. No problem. I'll provide you all these files now. You have to practice, that's all. Once you practice, you can easily show it to your guide. Nothing is there.